Welcome to an overview on opportunities for waiving inhalation studies for pesticides. My name is Monique Perron, and I'm a toxicologist within EPA's Health Effects Division in the Office of Pesticide Programs, which is also referred to as OPP. I'm going to start with providing some background information on OPP's guiding principles for data needed to support pesticide registrations, provide some information about the weight of evidence approach OPP uses when considering inhalation study waivers, and introduce a new approach methodology that is being proposed to refine inhalation risk assessment. In 2013, OPP came out with a document on guiding principles for data requirements. This document was developed to help OPP staff focus on information that's most relevant for pesticide assessments and reach the overall goal of ensuring there's sufficient information to reliably support registration decisions, while also avoiding the generation of data that does not influence the scientific certainty of a regulatory decision. As such, we can avoid unnecessary use of time and resources, data generation costs, and animal testing. The guiding principles promotes and optimizes full use of existing knowledge, while also providing consistency across the OPP divisions when determining data needs. Ultimately, decisions regarding data needs are typically on a case-by-case basis and consider all of the available information, including physicochemical properties, metabolism data, toxicological profiles, exposure patterns, and available human information. Additional information on structural analogs may also be considered. Under 40 CFR Part 158, OPP requires toxicology data to support registration of food and non-food use pesticides. The CFR are government laws that provide the framework for our data requirements for registering pesticides. However, the regulations give EPA substantial discretion to make registration decisions based on what the agency deems are the most relevant and important data for each action. So under section 158.30, the actual data and studies required may be modified on an individual basis to fully characterize the use and properties of specific pesticide products that are under review. Also, the data requirements may not always be considered appropriate. For instance, the properties of a chemical or an atypical use pattern could make it impossible to generate the required data, or the data would not be considered useful in the agency's evaluation. As a result, section 158.45 permits the agency to waive data requirements, but must ensure that sufficient data are available to make the determinations required by applicable statutory standards. The 40 CFR also provides EPA with broad flexibility under 158.75 to request additional data beyond the Part 158 data requirements that may be important to the risk management decision. Alternative methods and approaches can be considered and accepted for these additional data when appropriate. The OPP committee responsible for considering waiver requests for required guideline studies as well as other non-guideline studies is called the Hazard and Science Policy Council, or HASPOC. The HASPOC has several goals. However, it should be noted that this committee does not review endpoints selected for risk assessment, but rather utilizes all available information to meet its goals. First, HASPOC develops overarching guidance and policies that allow OPP to accomplish its scientific and regulatory goals. HASPOC also strives to provide consistency across the divisions in OPP with respect to its use of data in human health risk assessments. They also build efficiencies into the risk assessment process. By identifying data needs for chemicals, studies that would not influence the scientific certainty of a regulatory decision are avoided. As such, fewer studies are submitted and fewer resources are spent by OPP to review and evaluate those studies. Additionally, risk assessment teams can focus on the most important issues identified in an assessment. Lastly, HASPOC's goal is to implement the 3 R's of animal testing: replace, reduce, and refine. Where appropriate, waivers are granted for required toxicity studies to reduce animal use. To refine, we may use special protocols instead of guideline studies. For example, using a shorter duration, fewer animals, or one gender. And finally, an example of replacing would be using other data, such as pharmacokinetic studies, in lieu of a toxicity study. In 2013, OPP also published a guidance document on the weight of evidence determination of data needs, which provides principal considerations for study waivers. This document covers the subchronic inhalation, subchronic dermal, neurotoxicity, and immunotoxicity studies that are required under Part 158. And although not specifically covered by the guidance, we still have flexibility to waive other guideline and non-guideline studies. If a study is required, though, the document also provides guidance on retaining a database uncertainty factor until the study is conducted and/or other information is used to fill the data gap. The weight of evidence approach used by HASPOC is a risk-based decision-making paradigm. It considers both the hazard and exposure of a chemical. HASPOC consists of numerous toxicologists and exposure scientists from across various divisions in OPP. The general considerations for waivers include those laid out in the guidance document just discussed. So for inhalation waivers, this includes physical chemical properties such as the vapor pressure and Henry's law constants, the potential for occupational and residential inhalation exposure based on the use pattern, hazard characterization, which can also include the acute inhalation toxicity information, as well as risk assessment implications. In general, HASPOC looks for inhalation risk estimates that are 10-fold greater than the level of concern for inhalation risk assessment. So for example, if the level of concern for risk assessment is 100, HASPOC would be looking for risk estimates greater than 1,000. And lastly, not listed here, but also again, the information from related chemicals may also help inform the need for an inhalation study. So you'll notice that the weight of evidence approach is not only based on hazard information. Risk is an integration of hazard and exposure, and as such, the exposure information can be critical to evaluating the need for a study since it reflects how the chemical is used. For instance, we can determine whether people will be exposed in their diets, how a worker will be exposed while they're using a product or after the product has been used, as well as how a person is exposed while using a product around their home or after the product is used in their home. The exposure pattern may also help determine whether a quantitative assessment is necessary given how the product is packaged or used. And lastly, risk estimates represent the risk from a chemical after considering both the hazard and exposure of the active ingredient. Since all of these components can inform the need for a study, HASPOC needs to understand not only the hazard of the chemical, but also the exposure to make informed scientific-based decisions. So since December 2011, HASPOC has considered 296 inhalation waivers, and 233 of those have been granted. Each year, OPP publishes an annual report on HASPOC savings. For instance, in 2016, HASPOC granted 153 study waivers overall, not just for inhalation studies, and this saved approximately 44,000 animals and over $16 million in the cost of conducting the studies. In 2017, 70 waivers were granted, saving about 41,000 animals and $10.4 million. So I wanted to change gears a little bit here, and as I mentioned earlier, EPA has substantial flexibility in the data requirements, including the use of additional data such as alternative methods and approaches when it's appropriate. The anatomy and physiology of human and rodent respiratory tracts differ in several ways that can impact changes in airflow and the deposition of substances that are inhaled. This includes the airway size and surface area, the complexity of the nasal turbinate systems, branching patterns, cell composition and distribution, and the anatomy of the larynx. And these critical differences can ultimately affect the ability of in vivo testing in rats to correctly predict the effects in humans. Furthermore, traditional in vivo studies are resource intensive in terms of animal use, expense, and time. So with respect to respiratory irritants, also damage in the respiratory tract can be seen at very low concentrations. And in some of these cases, a concentration where no effects are observed may not be established, and additional animal welfare concerns may also arise. So as a result, efforts to develop new approach methodologies for inhalation toxicity are being supported by the agency. And in particular, new approach methodologies that take into consideration the inherent differences between the rat and the human may serve as a refinement for human health risk assessment. So a proposal for refining inhalation risk assessment using an in vitro model was submitted by Syngenta for the pesticide chlorthalonil. The agency has previously required a 90-day inhalation study for chlorthalonil given the high toxicity demonstrated in acute and short-term inhalation studies, as well as risk estimates of concern. However, Syngenta indicated that the study was just not feasible due to the irritant nature of the chemical and animal welfare concerns. So the agency recognized the value of the proposed approach, not only for chlorthalonil, but also other respiratory irritants, and encouraged further development of the proposed approach. We also reached out to the NTP's Interagency Center for the Evaluation of Alternative Toxicological Methods, or NICETM, to collaborate with us on the review of this new approach. The Office of Pollution Prevention and Toxics, or OPPT, was also involved in the review, since this approach may also be applicable to industrial chemicals. So part of their submission, Syngenta provides a biological understanding of the respiratory irritation caused by chlorthalonil exposure. This includes an adverse outcome pathway beginning with cell death from initial contact and transformation of epithelium into stratified squamous epithelium following repeated exposures. And this biological understanding guided Syngenta's consideration of available in vitro models for assessing damage to respiratory epithelial cells. And ultimately, they selected a three-dimensional in vitro model that allows direct exposure at the air-liquid interface, and they also measured for several endpoints that were indicative of cell damage. Computational fluid dynamic modeling was used to predict site-specific deposition of chlorthalonil in the upper respiratory tract. CFD models utilize computational mesh based on species-specific anatomical data to determine airflow patterns and predict localized deposition of discrete particle sizes within each region of the upper respiratory tract. There have been CFD models made for several species for the upper respiratory tract, and this includes rats, monkeys, and humans. And the models also allow for human relevant particle size distributions to be incorporated into the assessment. Human equivalent concentrations for inhalation risk assessment were then calculated for each region of the respiratory tract by integrating the dosimetry and the in vitro test results. For the in vitro test, benchmark dose modeling was used for each of the endpoints to derive in vitro point of departure. And the total daily deposition of chlorthalonil was calculated from the CFD model results, which includes calculations to move to polydispersed particle distribution, since the CFD model generated results for discrete particle sizes. The calculations also allow for incorporation of relevant exposure durations. So all of this, Syngenta's ultimate goal here was for submitting this proposed approach is for the agency to utilize the point of departure obtained from the in vitro assay, which is based off of human tissues, for our inhalation risk assessment, and thus provide us with suitable information to waive the requirement for the subchronic inhalation study, but also providing a more accurate estimate of risk by incorporating the human relevant particle sizes. This proposed approach with chlorthalonil as a case study will be presented to our scientific advisory panel during the first week of December 4th through the 7th. We will be soliciting advice from the panel on the derivation of the inhalation point of departure from the in vitro assay and the integration of the in vitro point of departure to calculate human equivalent concentrations for the inhalation risk assessment. We will also be asking them for advice on when this proposed approach may be considered appropriate for other contact irritants, as well as other chemicals that can cause portal of entry effects in the respiratory tract. So all of the meeting information, documents, and panel member biosketches can be found at the link provided here on this slide. And I just want to thank PETA International Science Consortium for inviting me to present in this webinar series, and thank you for listening.